Yesterday, we talked about a few different facts. We talked about how the notation goes. The notation makes you think momentarily, possibly, if you know negative exponents, that it is a what? It makes you think it's a, but it's not. When you have this negative 1 next to an F or a G or an H with an of X after, or eventually next to a sign that equals a tangent, it does not mean reciprocal. What does it mean? Inverse. We talked about notation first of all. Then we talked about what an inverse actually does. What does an inverse do? It undoes. It undoes the original function. It's like an undo button, right? An undo for the adding of the 1, the multiplying by the 2, and the cube rooting of the cube rooting. However, did we learn yesterday that the order does matter as to what order you have the minus and the divided by and the cube? Yes. So we did talk about how there is a procedure that will help us get the order correct, and that procedure is to take, well, to first of all, technically, put in a y, because you might just have an f of x. So put in a y, switch the x and y, solve for y, but what was the last thing I said to do when you're finding an inverse? Replace the y with an f inverse because that is who you found. This example was a little too easy. We just skipped it. We did a harder one on the page before. Then we got to graphs. And we talked about how if you're looking at an original function and looking at its inverse, you should be able to see that they are reflections of each other across the line equals x line. So, to that end, if I was to give you something like, and I think there might be in your homework a couple tricky ones. You don't really have space in your notebook. Back of your spirals look like workspace. Workspace. We'll do 1.9. The directions are just to sketch the inverse function. The directions are just to sketch the inverse function. Here's one that always gets tricky. I don't remember if this is exactly what your homework is. Hold on, let's center them around it. Is that what center when he's symmetric? If this is F, now for those of you that did homework, I'm not saying sketch the inverse function. Maybe his inverse isn't a function. We'll talk about that in a second. I'm just saying sketch the inverse, and I'll put in parentheses relation. Example notes was much easier. But you know what line you need to reflect about. You need to figure out how to do that for this one. How would be nice and special? Maybe a different color pen or pencil when you answer this one. If you have to, now would be a good time to do it. talk about your groups real quick. It was a tricky one. Let's see if anyone was able to get it. And if you were able to get it, how did you think about it? It was a tricky one. How hard have you guys made it? We saw one yesterday. The problem was around the y and it became around the x. You ready to see how easy it could have been? Yeah. Piece by piece. Piece by piece. A lot of you guys got stuck trying to put the whole thing at once. Piece by piece. If you only had that little top part, where would this flip go? This little flipper, where would it go? Right? You flip it across, wouldn't you just go over there? If you were to fold that little line. Cool. Where would this piece go? Over here. Oh, like. Like that? We should be a little bit lower. Has more of a loop-de-loop. Do you guys see how this dips below the axis? Maybe I should have done it in more pieces. What have I just flipped so far? Just this piece, right? Flip him. How do I flip this guy? How about there? How do I flip this guy? A little bit more. How about there? How do I flip this guy? Have it come in. How do I flip that guy? There we go. Roughly, what do you guys think? Now check it. First I did this little piece, which was probably the easiest piece out of all of them. These ones are kind of the easy ones, little lines. They just flip. Then I went ahead and just flipped the next piece. And I said, oh wait, it needs to cross through the axis and have a little humpy dump. Okay, cross through the axis, have a little humpy dump. It's just going to be the other axis instead of the horizontal. It's going to be the vertical. Same thing here. I copied that piece and then it needs to pass through the axis, come back to the origin. But instead of the horizontal, it's passing through the vertical back to the origin. So, can sketching an inverse be tricky? Yes. If I'm asking you to sketch the inverse, and I ask you to figure out this guy's equation and find the inverse and graph it? No. Could that be a way of checking, sort of? Kind of? Maybe? I guess. But all I meant was use the property of that. You need to draw the line y equals x, and then think about how do I flip it piece by. Does that make it a little bit easier? Okay. Was it kind of hard to begin with? Yeah, it's a complicated graph, right? Okay. Let's come back to our notes. We talked about how in a graphing calculator, if you graph a function as inverse, if you cannot tell, you're supposed to see from like the graphs in your calculator if they're inverses. What did I say you should probably graph, just like I kind of did in the last one? Graph y equals x, yeah, and then you can look a little bit better. It's kind of hard to see if you don't have the graph there. We talked about how points switch, the order pairs switch. And that might be able to help you as well. The reason why it didn't help you in this graph, though, had I marked out any points for you to switch? No. If I had given you something like, I don't know, 1, -2, then maybe you could have done -2, 1 and gotten a point on the other curve. You could have done that. But I didn't give you that on purpose. But if you do have points of one function, yes, you can flip them and graph them on the other. And I think this is where we ended, right? The special adjective, one-to-one, invertible, it describes a function. The idea. It describes a function whose inverse, when I flip it, will still be a function. It in your workspace, the problem you guys just did, when we flipped it, we can go back to it. I can look at it real fast. When we flipped it, was the inverse of the blue one, was it a function, or is it a function, I should say? The blue one. No. Fails here. Well, anyway, it fails, right? Why, or what characteristic of the original made it so that when I flipped it, this one failed? Yeah. The original failed the horizontal, which meant when I flipped it, what's this one going to fail? That's what needs to be inverted. Now, did this red one still have an inverse? Yeah, it's not a function. Still has an inverse, just not a function. And if we were to solve for it, maybe it would have 2 to 3 inverse functions, like pieces by pieces. If you put them all together, that's the inverse. But it doesn't just have one inverse function alone. Like the one we saw yesterday, which we talked about, I think x squared, right? Did you guys finish this page already? Mm-hmm. We said this one was not invertible because technically, what does it fail? Can I still flip it and look at its inverse? But is it a function? Okay, so check these ones out. Which one or ones? Could be all, could be none, or any. You have a table and you have 2 graphs. The dotted lines are just to give you a representative horizontal line. Which one or ones are invertible? AKA 1 to 1. Yes, it does say which of the following functions. So you're not worried about whether or not they're functions. Only concerned about whether or not they're invertible. I think the hardest one is probably the table. What do you guys think? Is the table invertible or no? Why not? Each x is paired with one and only one y. No x's are repeated. Horizontal line test doesn't ask if the x's are repeated. What's x? Y's. Ooh. Now, this is a function. No x's are repeated with different y's. But are any y's repeated with different x's? Yes. And couldn't you guys technically in a table, can't you always, don't connect, well, they did say x squared. But if you were just to see the points, and if you didn't know it was x squared, couldn't you also just sketch the points and also look at it, right? I'm preparing you for harder functions, not this one specifically. But you could have graphed just a few and been like, oh yeah, that's going to fail. I don't even know how it's connected and it's going to fail. The horizontal line test. Good, so number 1 is a no. Or I should say the table is a no. How about the graph over here? Invertible, yes or no? Yes. And if you look at the function x cubed minus 1, maybe a lot of cubics will be invertible. What's going to happen to that cubic that's going to make it not invertible? Well, even, but that won't be a cubic. You guys know what can happen to a cubic graph when it's distorted? It's not always like that. It could be like that, but that's still fine. It can have different terms, like x squared terms and x terms, and it can get kind of skewed. So not all cubics are going to pass the horizontal line test. But all cubics without middle terms are going to be totally fine. And even some with middle terms will be fine as well. Yeah, so he's 1 to 1, and he's invertible. You guys already know the last one, right? He totally fails. Horizontal line test. All right. This might be where things got a little exciting last night. Not even those. This is where it really got exciting. Right there, domains, right? Anybody who's working on homework? Let's go ahead and just do, I don't know, which one looks harder for you guys? That's what I thought. Let's just do number 2. A lot of you have already started homework, so you've already probably done an example like number 1. Not that it's a bad example, just let's focus on number 2. I'm going to dream over here so there's no room. We'll skip number 1. Hard parts. I'm very grateful of number 2. It's the very first thing we're supposed to do. Ugh. We're supposed to see if it's 1 to 1. Do you guys know what the graph looks like? I know what number 1 looks like. It's a parabola and it fails. What about number 2? It is a line. It's a line with a hole. Not many people would know that though. Could you look at your graphing calculator and could you see what the graph, and I see a few of you looking at it, we'll have them double check it. You could look at your graphing calculator if it was a hard enough function. But maybe we could just start on B. Do you remember what happened yesterday when we were solving for the inverse of x squared that made us think maybe this isn't invertible without even thinking about the graph? What happened when we get going to solve? Let me write it before we had y equals x squared. I should say f of x equals x squared. No, no time. At least a few you can see what I'm doing. Okay. F of x equals x squared. To find the inverse, what did we do? And then we solved for what was the dilemma? I remember Patricia was helping me. What was the dilemma? A lot of it said. Yeah, a lot of us just said square root of x, no big deal. The problem is it's a plus or minus. How many functions are there? It takes 2 functions to make 1 inverse. I bet it wasn't invertible. What would happen in number 1 when we went to go square root both sides eventually? Wouldn't we have a plus or minus again? Ooh, once again, not invertible. For number 2, why don't we try to find the inverse and see if there's like a weird more than 1 function that it takes to find it. Does that make sense? So even if we can't see the graph, and some of you looked at the graph and you already know the answer, don't say it yet. We'll see if our math backs it up even further when we find the inverse. So, switch the x and y. You guys already do it? The f of x becomes the x. You don't like it, but it's not impossible. Anybody have any ideas about what to do next? Oh yeah, that division just messes me up. Multiply. I agree. People with SAT prep classes, they actually come with something similar. This is usually a number, and that's an x, and that's an x, and they're still like, I don't know how to solve. My directions are always the same. Division is becoming x. Multiply. Now what? You want to get everything in its simplest terms. So the division is a mess. Multiplying the other side, whew, at least the division's gone. But what do we still have going on over here? Multiplication. Undo, or I shouldn't say undo. Expand that multiplication. What am I saying? Get rid of as much as you can. Get rid of the division, check. Get rid of the multiplication, okay? And you can absolutely do it. Come on, kids, what do you want to solve for? Don't think division makes it harder. Okay. Make them think a little bit. Alright, what do you say?
Could you switch the x over to the other side, and then you could divide it and get rid of it? Or would that be
not division? So I'll show why. I do agree with subtracting the x to the other side. Here's the problem. If I divide by x, he seemed to get this y alone. All of a sudden, I just trapped that y. You see it? I could have the 5 over x, the y over x, and the x over x, but that y is still trapped. So I don't want to divide. Some of you, though, I think you saw what else you could do. I'm still going to subtract that x, but what's something else I might want to do? Add that y. I heard a few different things. Now, can I add 2x, y, and y? Are they like terms? No. But if I can get all the y terms on one side, there's this magical thing called factor. All of a sudden, the y that was in 2 places is now just in. Oh. Now I divide. Anytime earlier it would have been a problem. Ironically, what do you guys notice? Anybody down there yet? Every now and then a function is its own inverse. We got y alone. I substitute y for f inverse of x. Now hold on. We had to do something more. He really was his own inverse? How can I prove that to you mathematically? It's going to be a mess, but you ready? Mathematically, shouldn't f of g equal x if they're actually inverses? So what am I going to do with this guy? Plug him in. Woohoo! It's going to be fun. You guys can just watch if you want. Did I plug him in right? So now what? Simplify the complex fraction. I'm going to do it using my trick, which says find the little baby denominators that are messing everybody up and multiply the top and bottom by that little baby denominator. You're going to make some horrible mistakes if you don't realize that these are grouped. Bring in this little guy there. Ooh, they cancel, and you just have 5 minus x on top, because that cancels. He also gets multiplied by the 5, which I am going to distribute. You're right. On the bottom, I'm going to bring that guy in. Ooh, he cancels. So I get 2 times 5 minus x. Multiplying them there. Good so far? So on top I get 10x plus 5 minus 5 plus x. I did not kill a seal, I distributed that negative. Oh look, the 5's canceling. On bottom I get 10 minus 2x plus 2x plus 1. 2x is canceled. I get 11x over 11. Oh my goodness. That's one way. You're welcome. The other way is to graph it. My people that graphed it, what was weird about this guy? Graph the y equals x line. I'm going to get it up really quickly. What do you notice with the graph of this function when the y equals x line is in there? Oh my goodness, what's going on? Mrs. Christensen got me a new computer, so not all of my rights have gotten uploaded. What was the numerator, guys? Sorry, help me out real fast. 5 coffee. 5 minus x? Thank you, thank you. Who said coffee? Wait, hold on. I also said to graph y equals x, right? Struggle. Okay, what happened when you graph the two? It's its own reflection. Look. It's its own. No. Do zoom square. Remember, it's a little bit skewed because it's rectangular and not square, and we're trying to fit square coordinates in. Do zoom square. Is that any better? No? How could we check another way? Ready? Can I check what is the value at 1? Okay. The value at 1 is 4/3. So question, what should the value at 4/3 be? Pause. When x is 1, y is 4/3. So when x is 4/3, if it truly is the inverse, what should y be? Exactly. Let's see if it actually works. It does. We can do that with any point. You try an x and try the y, and then try the y as the x and get the y. As I just got lost. Anyway, the point switch. The end. Dun 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 dun. It is its own reflection, in case you guys were wondering. Okay. Weird, crazy, true, the math proves it. Let's do last example. The weird domainy one, and I bet that's what some of you guys got stuck in. And that's actually the last thing we have to do. You guys already did section 1.7, which had to do with transformations. This function is just an absolute value function that's been transformed. True? Absolute value function has been transformed. Specifically, if we wanted to see all the transformations that have occurred, since all this is going on the inside, we could pull out the 2. Because either has been a translation. What do you guys think, right or left? Good, a shift or a translation left 1/2. And you could either think of it as a vertical stretch by 2, which would be the same thing as a horizontal shrink by 1/2 in this example with this function. The long story short, it's all based on what graph? What's the parent function in all this? Take away the transformations.
Absolute value of x.
What's the problem with absolute value and us thinking about inverses? Just a normal absolute value, what does it do? So he doesn't have an inverse function, right? So what are the directions telling us to do? What's the domain right now of this function? All the numbers, forever left, forever right. But what happens when I include all the left and all the right? What's it fail? So it says cut it down to where it has still all the y's from 0 to infinity, but it doesn't have all the x's. It doesn't have the repeated y's. Cut down the x's so that there are no repeated y's. Or technically less than, but that's kind of awkward. Now, hold on. So let's do that like wait. That's the normal absolute value. This absolute value has been shifted, right? So if we were to sketch this absolute value, Colby, how'd you think of -1/2? I can figure that one out. It was shifted. Absolute value has a point on the origin normally, but what happened to this guy? He got shifted. And he got vertically stretched. I mean, we could make it super precise, but long story short, he's going to be a little bit taller, right? We can actually find the y-intercept by setting x equal to 0. Oh, so it's going to hit it like 1. Okay, there's 1. I made it up. Okay. But the long story short, here's my graph. I cannot have it fail. I cannot have it fail the horizontal line test. Which means that this is -1/2. Am I allowed to have x's above and below -1/2? Because if I had above and below, isn't it going to have some pieces of the graph that are going to fail the horizontal line test? So when it says restrict the domain, if I can figure out what the graph looks like specifically, I can go ahead and say, sweet, I need to find the place or the point or the line where I can cut this graph and just take one branch, one portion, one side have all the y's from 0 to infinity still, but not have the repeated y's on the other side, which is why for letter A, we are going to say, we could go less than or equal to. That's kind of awkward. Why go to the negatives if you can go positive? There's a life lesson in that if you think about it. But anyway, we'll go positive. And if we were to take this portion, if we were to only look here on, think we're cutting at -1/2, we're ignoring this side altogether. Can we find the inverse of just this part? And will just this part have an inverse function? Yes. Similar to yesterday when we were talking about the parabola. We were talking about the whole parabola. Can I find an inverse function of the whole parabola? No. But can I find an inverse of just half of it? Yes. So I could say, okay, well, x squared in and of itself is not invertible because it has two functions. But if I was to restrict the domain, and if I was to say I only want x squared from or for x greater than or equal to 0, what would I say the inverse function is? If I was to cut the parabola down and only look at the positive half, I could say, well, the inverse function of only the positive half is positive square root. The inverse function of the negative half would be negative square root. So if they allow me to cut it down, I can say, oh, there will be an inverse function. Now here's the crazy thing though, what will the inverse function be? What do you guys think we're supposed to do behind it? Yeah. Let's take out the absolute value and say, well, if x is greater than or equal to -1/2, aren't I just talking about the positive parts of this? So I'm just talking about the positive parts of this. When I see the math for what I'm actually doing, I'm remembering that every piecewise function is equal to one part where the inside stays the same and one part where the inside switches. However, the place that separates the separator of the two pieces is going to be the 0. So I'm not going to use x greater than or equal to 0, x less than 0. I'm actually going to use 2x plus 1 greater than or equal to 0. When I move the 1, divide the 2, that's how I get my -1/2. So for anything greater than or equal to -1/2, the absolute value doesn't change anything. For anything less than -1/2, the absolute value is going to flip. And I'm saying, well, I don't want the 2 branches, I just want 1. So I'm only going to look for this part where the domain is x greater than or equal to -1/2, which means for letter B, I can just say, sweet. Switch to x and y, solve for y. Which I can solve for y by subtracting 1 from both sides and then dividing everything by 2. Subtracting 1 from both sides, then dividing everything by 2. But the other way of writing that, that's a little bit nicer to see, is you divide the x by 2, or by 1/2. You divide the 1 by 2, or multiply 1 by 1/2. But we know when we find the inverse, how do we finish that off? Good. We have to identify him as who he truly is. That is the inverse function of the only piece that I chose. I'm ignoring half so that I can find the inverse function of them. Now it's a little weird. You can start with the graph. Bless you, bless you. Think about what x's would hold or have a branch that is invertible and ignore the part that would make it fail. I did some math to show how I could have figured that out without the graph, just to let you guys know. For that piece, switch the x and y, solve for y, and make it f inverse. And I think we're almost done. Oh, state the domains and ranges of each. All right, last piece. Kiddos, you can see the graph, right? So we have for f, and we have for f inverse. Okay, for f, we already know the domain because we made it, I think, didn't we? Yeah. So x is greater than or equal to -1/2. And what did we need to keep the range? What was it to begin with, and what did we keep it? Yeah, good. Y can only go down to 0, but I needed all of the 0 to infinity. So y is greater than or equal to 0, or in interval notation, close bracket 0 to infinity. So what's going to happen with the inverse? Without even worrying about the equations. If we know the domain and range of the original, our job is easy. That's all we have to do is just be careful. If you're switching, it's no longer y greater than or equal to 0. What is it? Okay. And it's no longer x greater than or equal to negative 1/2 x. That's enough for you guys to at least be able to tackle those problems anew tonight. If you need to go back and look at any of the ones where you did have the restricted domains. Okay, guys, I'm just looking real fast as to where that weird restricted domain one was. Well, that was a funny one. 73? Oh, it was an odd struggle. Okay. For sake of time, I want us to start section 1.10. So even though I did have you guys HPrecalc pens out, let me go ahead and let you guys finish up whatever today might have helped with, specifically number 73, but you might have had some other ones that some of the things that we did might have helped with as well. Basically, we're just going to start off tomorrow's class really quickly with checking our evens on 1.9. Let's try to get just a few notes of 1.10. That way, don't worry, this is not notes. That way we can just jump in as soon as we check 1.9 tomorrow. And then if you guys do have questions on 1.9, you're like, I'm just not sure they'll get answered in class, come on in, don't lunch after school. What's this illustrating? How much we like word problems. Right? Okay, don't worry. I have to make anything that ridiculous, and that's not even a real problem, right? That was just a joke. A little bit tongue-in-cheek, but section 1.10 does have everything to do with math modeling. The struggle, why can't we just ignore word problems? They're so dumb. They're the introduction to how the math can actually get applied. And instead of making you guys take whole classes, math electives of applications of math in the real world, well, I guess calculus kind of is that. Physics kind of is that. Oh, chemistry is too, actually. Interesting. Statistics, if we still had it, personal finance, so that's kind of real life. So instead of you taking classes like probability, which is one in college, or combinatorics, or we'll learn about stats, business, accounting, intro to engineering. We don't have those sorts of things in high school, sadly. We don't let you specialize that much that quickly. Somebody way back when decided that high school needed to be about general education in the States. So you get a lot of very different subjects instead of letting you specialize early. In other countries, you start specializing really early. But it's based on test scores. It's not based on what you know. It's based on what you can prove that you can do. So you might think of maybe that would be so fun in the States because maybe you want to do something you're not sure if you can. Then they say you go to trade school, forget education, you're done. And that's how it is in the family. And a few other places. Super interested to study educational systems other than the U.S. What you guys are seeing right now is basically what we already talked about, that math models. We can model math with words, yes, with tables and data points, yes, that's statistics mostly. With graphs and algebraically. We've already talked about regression feature in our Precalc Graphing Calculator handbook, so if that does come up again in homework at all, you guys can go back to your handbook and review how to enter data into lists, run a regression, etc. But that is not the point of this section. And this information, none of not specifically. We're not going too deep into stats, so you don't need to memorize any of this. Just the idea of, remember, you can take data, you can use a regression feature in order to be able to find equations that seem to basically model. Colby, go ahead.
How would you become a coach
How would you become a coach?
with that system?
What?
How would you become a good soccer coach?
Easy.
It would be a volunteer job. Or you would have connections to teams that actually pay. But in a lot of those countries, you don't get money for doing entertainment things like that. Does that make sense? Cool kids. 110. Oh, 1.10. Could you start because it has some tables? It's Pre-Calc Graphic Calculator Handbook, right? Not too bad. We need to focus tomorrow on the tricky words. Alright, cool kids, make sure you have 1.9 done. Start 1.10, anything with tables. Otherwise, pause, and we need to cover a lot tomorrow. We'll see if we can still have the test on Monday. Bye, guys. First slide? Oh, I have 110? Yeah. There you go. If anybody wants to support tennis, Krispy Kreme's $1 over on my thingamabob.